Okay, this is lesson 3.2, Maxima and Minima of quadratic relationships. We can use quadratic formulas to model scenarios including maximum and minimum revenue, product of numbers, area, and path of projectiles. And we're going to do a couple word problems today surrounding those topics. The first style of question would be a revenue question. There's a couple different ways that you can model revenue, and it comes from the idea of what revenue is. And revenue is just how much money is generated in a scenario. So one way you can determine revenue is you can multiply something called a demand function by the item of numbers sold. And the demand function is just the price of an item and the number of items sold. It's the relationship between those. And the example we're going to do gives you a demand function, and we use the demand function, p of x, multiply it by x to get our revenue function. So again, it's basically just price times number sold. That's how we're coming up with revenue. Another relationship involving revenue is profit. Profit is just the revenue, how much money you make, subtracting away the cost, so how much the item costs. And that leaves you with profit, the extra money. And sometimes we're optimizing profit as well. Some other things we need to be familiar with are break-even point. A break-even point is basically where you make zero profit, or it's where the revenue and the cost are the same. So the example we're going to do today in the video is a optimizing revenue question. We're going to look to find the maximum revenue. So how can we make the most money? And we'll do a warm-up in class where we don't do this style of question. We'll use profit, and we'll optimize profit. So you kind of get to see both examples, and there'll be various examples in your homework surrounding them as well. But let's take a look at what we've got here. I'm going to keep those at the top. The demand function for a new BioShock Infinite video game. New. So that's from 2013, so that's not new anymore, but anyways, is p of x equals negative 4x plus 24, where p of x represents the selling price in thousands of dollars and x is the number of video games sold. We want to find the maximum revenue. In order to do that, we need to write a revenue equation, Rx, and since we're given little p of x, we can use this equation to make our revenue. The number sold times the demand function. So our demand function is negative 4x plus 24, and x is our variable, number sold. So we've got number sold times profit. Number sold times profit is negative 4x plus 24. And if we expand and collect like terms, we end up with a revenue equation that is negative 4x squared plus 24x. And there's our revenue. Since we want to find the maximum revenue, we want to find the vertex. And our equation is in standard form or expanded form. To find the vertex, we need to complete the square. So let's complete the square. Group the first two terms and common factor the negative 4. We end up with negative 4 bracket x squared minus 6x. To make a perfect square trinomial, to factor, we need to take that negative 6, divide it by 2, and square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So we get negative 4 x squared minus 6x plus 9 minus 9. And now we only need the first three terms in our perfect square trinomial. So we're going to take the negative 9, multiply it by negative 4, bring it outside, we get 36. And our last step is we're going to factor that perfect square trinomial. Negative 4 is our a. Since it's negative, that means it opens down, which means our vertex is going to be a maximum. So we've got the right equation here. Square root of the first term is x, sine from the middle term is negative, square root of the last term is 3, plus 36. So we wrote our demand function in standard form, we converted it to vertex form, we ended up with a vertex. So I'm going to write the vertex. Vertex is 336. So what are the 3 and the 36? Well, 3 represents our x because it's in the x position, and 36 is our y, but we weren't working with x's and y's, we were working with x's and r of x's. So 36 is our r of x. And now if we go look at our variables, x is the number of video games sold. So if we sold, number of video games sold in thousands. So if we sold 3,000 video games, therefore, if we sold, it's not we that are selling them, but anyways, we sold 3,000 video games, the revenue would be maximized at, and revenue was 36, and we're working in thousands of dollars because the selling price is in thousands of dollars. So we've got $36,000. And that's how we can do a optimization of revenue. I keep using the word optimization. Optimization just means the minimum or maximum. And in the context of the question, you'll find either a minimum or maximum. Since it's a revenue question, we'd be looking to maximize revenue. So optimizing revenue would mean finding the maximum. Okay, let's try a different style of question. We've got product of numbers. So if we want to find the maximum product of two numbers whose difference is 12, what are the two numbers? Well, start with some let statements. Let's say let A be the first number. And let B be the second number. Well, what do we know about A and B? We know that their difference is 12. So that means if we subtract A and B, we get 12. We want to find the minimum product. So we have to write a product equation. I'm going to work over here to write my product equation. What does product mean? Well, product means multiply. So we want to multiply A and B. But we can only work with one variable. Since we've got A and B, that's two variables. So we need to use this piece of information and replace either A or B so we can have a single equation with a single variable. So let's replace B. If I wanted to replace B, I could isolate for B. So I'm going to move B to the right side, make it positive. Subtract 12 from both sides. We get B is A minus 12. So let's go back over here. I'm going to replace B with A minus 12. And now we've got an expression with only A's. And if I distribute, multiply the A's out, we end up with a quadratic. A squared minus 12A. And since we've got a quadratic, we can find the vertex. And since the A value, the coefficient on the squared term, is 1, that means our parabola opens up, and that's going to allow us to find a minimum. We're looking for the minimum product. So again, we're looking for the vertex. So let's look for our vertex. Oh no, we're not looking for the minimum product. Well, I mean we are, but the actual question says what are the two numbers. So we're going to find the two numbers. Here we go. We have a quadratic in standard form. To start making it vertex form, group the first two terms, common factor what's in front. Hey, there's nothing there. So we can actually skip that first step of grouping the first two and common factoring whatever's in front, or partial factoring. What we do need to do next is take that negative 12, divide it by 2 and square it. So we've got A squared minus 12A divided by 2 is negative 6, square negative 6, we got 36, and subtract 36. Alright, we want to now group those first three terms, because that's where our perfect square trinomial is, leave the negative 36 on the outside, and factor. How do we factor? Well, square root of the first term is A, sine from the middle term is negative, square root of the last term is 6, and squared negative 36. So let's look at what our two numbers are. We've now got a vertex. Our vertex, I'm going to work over here. Our vertex was 6, negative 36. So what did we use in our equation to find our vertex? Well, we used a's. So the first number is our a. And what's a? A is the first number. So the first number that maximizes the or minimizes the product is 6. And negative 36 represents our y in our vertex, and in the spot of a y in our equation is product. So our product is negative 36. So therefore, if the first number is 6, what's the second number? Well, back over here, b would be a minus 12. A is 6. 6 minus 12. 6 minus 12 is negative 6. So b is negative 6. So therefore, the two numbers that minimize the product are 6 and negative 6. And the difference between 6 and negative 6 is indeed 12. If we subtract those two, we get 12. So let statements first. Use the information to write an equation. Use what we're trying to find the minimum or maximum of to write a second equation, a product equation. Turn the product equation into a single variable. Expand, collect like terms, and then complete the square to find the vertex. Okay? We'll do lots of practice with these word problems. In fact, we're going to do one more style now. These might turn into your favorite. Projectile questions. The nice thing about a projectile question is it gives you the equation. You don't have to build an equation. At the SDHS basketball game, blue and white tosses t-shirts to spectators in the stands out of a slingshot. The height of a t-shirt is modeled by this function. Height equals negative 5t squared plus 20t plus 1, where h of t is the height in meters and t is the time in seconds after the toss. What's the maximum height of the t-shirt? And we know it's maximum because if we look at our equation, we've got a negative leading coefficient, which means that that parabola is going to open down, which means we're going to have a maximum. So we're just looking to find the vertex of our height equation. And since we're looking for the maximum height, we're looking for the y of the vertex because the h is in the spot of a y if we're using x's and y's. So this one should be pretty straightforward. All we're going to do is complete the square, and the answer should be the y of the vertex. T plus 1. So complete the square, group the first two terms, and common factor the negative 5. So we've got negative 5 in front. T squared minus 4t plus 1. Take the number in front of the second term, negative 4, and divide it by 2, which is negative 2, and square it, which gives us 4. So the number we're adding and subtracting is 4. And that's just completing the square. The last term is the one we don't need. Multiply it by negative 5, we get 20, bring it to the outside. Negative 4 times negative 5 is 20, so we got 1 plus 20. And now we're going to factor what's in our bracket and add the 20 and 21. I'll do the adding first. We know our bracket's going to end up squared. We've got 21. Let's factor. Square root of the first term is t, sign from the second is negative, and square root of the last term is 2. So our vertex is 2, 21. Now if we go look at our equation, we can figure out what the 2 and 21 represent. We've got an x and a y of the vertex, so go look at your equation and look at what's in the x and y spot. In the x spot is t, so 2 is the time. At 2 times in seconds, the t-shirt reaches a maximum height, and we know its height because in the spot of y, x and y of the vertex, and the spot of y is h of t. That maximum height is 21, and h is in meters, 21 meters. That's how we can take our vertex and turn it into an expression. The last question is an area style question. We're actually going to do that in class tomorrow. And that's it for lesson 3.2. And I will see you next time.